Hi class, so this is the recap of what you watched in the 5-5 day 1 video. Be sure after you watch this all the way through to the end, and make sure you watch it till the end because it's your attendance today, that if you didn't watch that 5-5 video, go back and watch it before you try your Pearson. Okay, so we're just going to do a few examples of what the video went over. The first thing we are going to do is practicing adding two functions. So we started seeing this new notation where it just says do f plus g. Well, that's saying take function f, so the 3x squared plus 5x plus 1, and add function g. So when it's addition, it's nice and easy, plus 2x minus 1. To finalize my answer, I just need to put it in standard form, which means I need to combine like terms. I see a 3x squared, that's the only one with an x squared. I see a 5x and a 2x, so that's plus 7x. And finally, a positive 1 and a negative 1, those cancel. So my final answer is 3x squared plus 7x. The other thing we saw for all the different types of problems we're doing in this video is that we need to also state the domain. We're not worried about range, but just the domain. Remember, domain is what possible x values could I plug in? And really what they focused on is you have to look back at the original functions. So f of x, that's a quadratic. It's an x squared graph, which I know the domain of all quadratics is all real numbers. G of x is a line, because 2x minus 1 is a line, which is also all real numbers. So if the domain of both your originals is all real numbers, that means that it's all real numbers if you add them together. All right, number 2 here. This time we're going to subtract. Now I'm actually going to change it, and we're going to do g minus f. Make sure when you're doing your Pearson, you're careful and you notice which one comes first. If it's addition, the order doesn't matter, but as soon as it's subtraction, order does. So if I'm doing g minus f, that means I take the g function first, so 2x minus 1, and I need to subtract the entire f function. So the big thing with subtraction is make sure you put the second polynomial that you're subtracting inside parentheses. You don't have to necessarily show this step, but what you need to understand is that, so I have 2x minus 1, I need to take the opposite of every single piece because I'm basically distributing a negative. Okay, so that is the one twist when it's subtraction. My final answer, if I did g minus f, now I find like terms. I have the negative 3x squared. I have a positive 2x minus 5x gives me minus 3x. This time I have a negative 1 minus 1, which is minus 2. So my function g minus f would be negative 3x squared minus 3x minus 2. And again, these are the same two functions in the last one. So since both originals domain were all real numbers, the overall domain of g minus f is also all real numbers. All right, the third thing we started to look at is what if we ask you to do f times g? So that's a multiplication sign when it's just a filled in dot between. Well, that's saying, okay, let's take x squared plus 2x plus 1 times x minus 4. And again, we did this a few chapters ago. This one happens to be a binomial times a trinomial. So I would do the box method. Squared, 2x, and 1. Okay, length times width is x cubed. This gives me 2x squared, 1x. This gives me negative 4x squared, negative 8x, and negative 4. And when we use this box method, then we combine like terms of the boxes. I get x cubed. These diagonals add together. I get minus 2x squared, minus 7x, and minus 4. So again, as we're looking at this, what we're noticing is that we're actually doing the same skill work we did back in the polynomials chapter. We're just using function notation and understanding that you have to identify that f times g means take function f times function g. Okay, so that's f times g. Now, the domain of this, and again, this came up in the video, you'll want to make sure that you get it down somewhere. The domain is the intersection of what you're multiplying. So the intersection of the domains of what you are multiplying. Now, in this case, it's again all real numbers because I have a quadratic domain is all real numbers and a linear. So the domain of this one in particular is again all real numbers. But in the video, it does show some exceptions to that rule. Now, the other thing I will say is make sure you watch the video for the multiplication. So even though this is what you do when you have two functions, The multiplication problems usually are more real-world application problems, and Miss Green does show an example of how you will use that, which is similar to the homework. So that comes up in the video. I'm focusing more on the skill work. Okay, the final thing we have to be able to do is to divide functions, okay? So that f over g, another way you'll see it in Pearson is they'll show you f over g of x. If they're saying do that, just f over g or f of g of x, you're really just taking the f function, so f of x, and you're dividing it by g of x. So we're going to take the f function, which is x squared plus 2x plus 1, and divide it by x minus 4. Now again, that's the setup, but the bigger thing is again, we learned, this is called a rational expression, when we have a fraction of two polynomials. And we learned about this. We actually learned how to simplify this way back in, I can't even remember what chapter, but this is where we actually have to factor everything on top and bottom to simplify. Okay, so when we go to factor, x squared plus 2x plus 1, and again, Miss Green reviews that a little bit in the lesson, x plus 1 times x plus 1. Because remember, if the leading coefficient is 1, I'm thinking of two numbers that multiply to 1, and then add to that middle number. Okay, now if this number changes, it adds another layer. And again, Miss Green reviews that in her lesson. But we are not allowed to forget how to factoring ever. Now the unique thing about this problem is it does not actually have anything that cancels. Okay, so this is my final answer. But remember, you'd be looking to see if a factor on top cancels with a factor on the bottom. And then finally, the domain is, again, when we're talking about fractions, domain, we have to look for what makes denominator 0. And x can't equal that. Okay? And here's the other key, even if you cancel it out. Okay? So what I mean by that is when I look at this function, my f divided by g, I have x minus 4 in the denominator. That can't equal 0 because we know we can't divide by 0. So the strategy is then we solve it for x, so x can't equal 4. Okay, so my domain is all real numbers except x can't equal 4. Okay, so that'd be my domain for this particular answer. Now just a quick little side note. Again, let's say we went through this division. So this is, let's say we ended up with something where we had like x plus 5 times x minus 3 over x plus 5 times x plus 2. Let's say through this process when you were factoring, that's what you got. Remember, in this case, the x plus 5's cancel. So I have x minus 3 divided by x plus 2. So this is my simplified answer. But when I go to do my domain, I see the x plus 2 in the denominator, so I know x plus 2 can't equal 0. But don't forget that x plus 5 that you canceled out, that also can't equal 0. So in this case, my domain is that x can't equal negative 2, x can't equal negative 5. Okay, so this is kind of what I was referring to up here. Miss Green, again, does a couple of examples of it like that. The example we had on here just didn't happen to have anything canceled. So I wanted to make sure you recognize that. And again, some of the factoring will be a little more tricky, meaning there will be a number attached to the x squared. And once again, she reviews that in her video. Okay, so I promised I would keep this video short because this was just to really summarize and recap what you should have already seen. So make sure you play this for 10 more seconds till the end. Once it finishes, then if you didn't watch the video, go back and do that, so that you understand what you're doing. And then today's assignment is 5-5, day 1 Pearson practice, but that'll be due next Monday. All right, thank you so much and have a great day. We'll see you tomorrow.